Welcome to Study Loop.
In this problem, it is said that about 45% of the US population has type O blood, 40% type A, 11% type B, and the rest type AB. So we can conclude that the probability that a person will have type O blood is 45% or 0.45. Type A blood is 40% or 0.4. Type B blood is 11% or 0.11. All these probabilities does not sum up to 1 or 100%. They sum up to 96%. So the probability that a person will have type AB blood is 100% minus 96%, which is equal to 4%. Or we can write it as 0.04. Now the first question asked is, someone volunteers to give blood. What is the probability that this donor has type AB blood? We have found the probability that a person will have type AB blood to be equal to 4%. So this probability is equal to 4%. Now the next question asked is, what is the probability that this donor has type A or type B? We know that having a type A blood or a type B blood are disjoint events, as they both can't happen at the same time. So we can use addition rule to find this probability. Probability that a person has type A blood or type B blood is equal to probability that the person has type A plus the person or that this donor has type B. Probability of A is 40% and that of B is 11%. So probability of A plus probability of B is 40 plus 11, that is 51%. Now in the next question it is asked, what is the probability that this donor is not type O? The donor is not type O is the complement of the event that the donor is of type O. So by complement rule, this probability is equal to 1 minus probability of O. Or if written in the form of percentage, this is equal to 100 minus probability that the person or this donor is of type O. The probability of O is equal to 45%. So this is equal to 100 minus 45%, which is equal to 55%. Now in the next question it is asked, among 4 potential donors, what is the probability that all are type O? This can be denoted as, the first person is of type O, intersection, second person is also of type O, third person is also of type O, and fourth person is also of type O. We have to find this probability. We know that all the 4 persons are independent of each other. That is, their blood type is not affected by blood type of any other person. And so we can use the multiplication rule for independent events. And therefore, this probability is equal to probability of O multiplied by probability of O multiplied by probability of O and again multiplied by probability of O. That is probability of O multiplied 4 times, or we can write it as probability of O raised to 4. The probability that a person or that a donor has type O blood is 0.45. So this is equal to 0.45 raised to 4. And so this is equal to 0.041. Now, in the next question, it is asked, what is the probability that among the 4 potential donors, no one is type AB? We don't want anyone to be of type AB. That is, first person is other than type AB, so we can write it as AB complement. Intersection, same condition for second person, so it must be AB complement. Again intersection, AB complement. We don't want them to be of AB, so they can be any blood type other than AB, and so we are writing AB complement. As all the 4 persons are independent of each other, using the multiplication law, this probability is equal to probability of AB complement. Probability of AB complement raised to 4. So this is equal to, as the probability of AB is 0.04, by using complement rule, probability of AB is 1 minus 0.04 raised to 4. So this is equal to 0.96 raised to 4. And so this is equal to 0.849, which is our required probability. Now, in the next question, it is asked, what is the probability that among 4 potential donors, they are not all type A? They are not all type A. Means either 0 is of type A, or 1 person is of type A, or 2 persons are of type A, or 3 persons are of type A. But not all the 4 persons are of type A. So the complement of this event is that all 4 persons are of type A. So we have to find the complement of the event, the probability for the complement of the event that all 4 persons are of type A. We have to find its complement. So clearly this is equal to 1 minus probability of all the 4 persons being type A. We have written this using the complement rule. By complement rule, the required probability is equal to 1 minus probability of all 4 persons being type A. As all the 4 persons are independent of each other, using multiplication rule, this probability is equal to probability of A raised to 4, that is multiplied 4 times. So, this is equal to 1 minus probability of type A is 0.4 raised to 4. So, this is equal to 1 minus 0.0 256, or that is equal to 0.97. So, the required probability is 0.97. Now, in the next question, it is asked, what is the probability that at least one person is type B? That is either one person is type B, or two persons are type B, or three persons are type B, or all the four persons are of type B. The complement of this event is that none of the four persons is of type B. That is 0% is of type B. This is the complement for this event. That is, we have to find that probability of B equal to 0, that is 0% is of type B. Its complement, the probability of its complement. Now, this is equal to probability of first person. We have taken, there is no one of type B. That is, first person is not of type B. So, B complement. Second person is also not of type B. It is also B complement. Third person is also not of type B. Again B complement. And the fourth person is also not of the type B blood. That is, we have got that no person is of type B blood. This is equal to, as the four persons are independent of each other, this is equal to probability of B complement raised to 4 using the multiplication rule for independent events. Now, probability of B complement is 1 minus probability of B, that is 1 minus 0.11 raised to 4. So, this is equal to 0.89 raised to 4, or which is equal to 0.627. This probability we have found that for no person has type B blood, but we have to find the probability for its complement. So the required probability, that is the probability of at least one person is type B, will be 1 minus 0.627, and which is equal to 0.3 0.373. That is, the probability that at least one person is type B is 0.373, which is our required probability.